What if NASA found conclusive proof of alien technology, but decided to hide it from the world? 3 weeks ago, a hacker group calling itself Event Horizon claims to have done the impossible, pulling 24 gigabytes of classified mission data from NASA's secure servers. The target? A mission to intercept 3I Atlas, the third interstellar visitor ever detected. The files hint at a cover-up of cosmic proportions. So, what did they find that was so disturbing? Let's explore this together. Event Horizon's cyber attack. So how does a clandestine group get its hands on NASA's crown jewels? According to the leaked security logs, this wasn't a brute force attack, it was surgical. In the early hours of September 2, 2025, Event Horizon executed a coordinated cyber attack that bypassed multiple layers of agency firewalls. They exploited a zero-day vulnerability in an outdated Fortran-based mission planning module, a tiny crack in an otherwise formidable digital fortress. The transfer rate was a blistering 571 megabits per second, far too fast for automated security flags to catch in time. Forensic analysts later pieced together a chilling timeline. The attackers gained initial access at 3:14 a.m. Eastern, escalated their privileges to the highest level by 3:19, and began siphoning data at 3:23. In under 7 minutes, 24 gigabytes of compressed files including internal chat logs, draft reports and sensitive telemetry from the 3I Atlas intercept mission were gone. By 3:30 a.m., the connection vanished, leaving behind nothing but a silent gap in the audit trail. Cybersecurity expert Mikko Hipponen has stated that such an attack would require nation-state level resources, suggesting Event Horizon is far more sophisticated than a typical hacktivist group. The manifesto and distribution. A successful hack is one thing, but what you do next is everything. Hours after the breach, a manifesto from Event Horizon appeared on encrypted forums accessible only through the Tor network. They claimed full responsibility, framing the attack not as an act of digital vandalism, but as a necessary response to what they termed unlawful cosmic secrecy. Their message was a direct challenge to the global intelligence status quo, echoing the methods of groups like WikiLeaks but with a far more specific target. They warned that the leaked files contained material so sensitive that even senior directors at NASA were allegedly kept out of the loop. Their language was blunt: the world deserves to know what its own scientists have found. But Event Horizon didn't just dump the data online. Instead, they began a calculated campaign, distributing blurred screenshots and heavily redacted memos to select journalists and online channels known for covering classified science. No one received the full archive. It was a strategic drip feed, designed to build pressure and credibility, giving the world just enough of a glimpse to understand the immense gravity of what had been taken. Their final warning was a gauntlet thrown down. The files contain evidence that will force the public to confront a new reality. Authenticating the documents. In the world of leaks, authenticity is paramount. So are these files real? The evidence presented by Event Horizon is compellingly layered. The leaked screenshots are plastered with authentic details: bold, block-lettered confidential stamps, thick redaction blocks and metadata tags showing UTC timestamps that perfectly match the breach window from NASA's own security audit. We see mission patch artwork in the corners, a stylized comet labeled 3I Atlas Int. Every document carries unique identifiers, routing codes, and internal chat handles you'd expect to see inside a major agency. Technical diagrams and draft tables use Courier font headers and bear NASA's internal digital watermark. We even see screenshots of the classic blue and white NASA email interface with subject lines like Atlas Intercept Immediate Action Required and Telemetry Review Anomaly Detected. One partially blurred memo lists technical trajectory data, while another redacted report is marked with the access level TS-SCI, denoting top secret sensitive compartmented information, a classification that restricts access to a small specific group of cleared individuals. The documents bear digital signature strings ending in -JPL for the Jet Propulsion Laboratory and -GSFC for the Goddard Space Flight Center, indicating a multi-center collaboration. Discovery of 3I Atlas. Before the leak, there was the discovery. On July 1, 2025, the real-life Atlas survey in Hawaii, a NASA-funded planetary defense system officially known as the Asteroid Terrestrial Impact Last Alert System, logged a new object tearing through the solar system at an astonishing 130,000 miles per hour, or about 58 kilometers per second. Astronomers immediately flagged it. This was the third interstellar object ever detected, following the bizarre 1I/Oumuamua in 2017, and the more conventional 2I/Borisov in 2019. But 3I/Atlas was different. Early estimates put its size at a staggering 26 kilometers across, roughly the size of the asteroid Vesta, and over 25 times longer than Oumuamua. Its trajectory, calculated by the Minor Planet Center, confirmed it was an interstellar visitor on a one-way ticket through our system, with an orbital eccentricity greater than 6.0. Its path was hyperbolic, meaning it wasn't captured by our sun's gravity, and would not be coming back. According to Dr. Larry Deneau, the principal investigator for the Atlas project, an object of this size and velocity is a once-in-a-century detection event. This wasn't just another icy rock, it was an unprecedented anomaly from deep space. Impossible physics and trajectory. Here's where the story takes a sharp turn from unusual to unbelievable. Like its predecessor, Oumuamua, 3I/Atlas was not behaving according to the laws of physics. The leaked mission logs from July 18, 2025 show a sudden inexplicable sideways acceleration, resulting in a velocity change or delta V of 1.5 meters per second. The object changed course in a way that defied gravitational models. For a normal comet, such a deviation could be explained by outgassing, measured by the non-gravitational acceleration parameter A2. However, just like with Oumuamua, initial observations of 3I/Atlas showed no cometary tail, no dust and no gas coma to account for the push. Its A2 parameter was effectively zero, yet it was still maneuvering. Trajectory analysts were stumped. They ran models accounting for solar radiation pressure, gravitational pulls from planets, and every known natural force. Nothing matched the telemetry. Dr. Amy Mainzer, a leading expert on asteroids, has noted that explaining such a deviation without observable outgassing requires exotic physics or an artificial origin. The numbers kept pointing to a single, unsettling conclusion. Some force other than gravity was steering this massive object through our solar system. Surface anomalies. The armor problem. When the first high-resolution images from the Intercept mission were allegedly taken, the mystery of 3I/Atlas deepened. The object's surface looked nothing like any known comet or asteroid. Analysts flagged a disturbing pattern: bands of smooth, almost metallic-looking plating, broken by lines that ran too straight and were too evenly spaced to be natural fractures. These weren't the chaotic, jagged fissures seen on Comet 67P by the Rosetta mission. They were seams, crisscrossing the surface in a deliberate grid. One analyst, in a leaked internal chat, dubbed it the radiator problem, referring to a network of raised ridges spaced like the cooling fins on a spacecraft. These ribs cast long, uniform shadows, and their regularity was so pronounced that pattern recognition software reportedly flagged them as artificial. The object's albedo, or reflectivity, was measured at 0.7, closer to polished metal than the asphalt-dark surface of most comets, which have an albedo below 0.05. Planetary geologist Dr. Carolyn Porco has emphasized that nature does not produce such perfect, large-scale geometric patterns. This wasn't just an odd rock. The leaked images suggested it might be wearing armor. Thermal signatures and heat pulses. If the surface looked engineered, the thermal data was even more alarming. According to the leaked files, infrared arrays recorded heat vents pulsing with incredible regularity. The logs show heat pooling along the strange ribbed seams, and then bursting outward in tight, directed jets. This wasn't the broad, chaotic outgassing you see in a typical comet. These were discrete, timed pulses occurring precisely every 90 seconds, raising local surface temperatures by over 200 degrees Kelvin in an instant. The mission logs classified this as a directive motion event, a term typically reserved for spacecraft thrusters, not natural phenomena. Even more damning, trajectory analysts correlated these thermal pulses directly with the object's mysterious course corrections. After each 90-second heat burst, the Intercept team logged a subtle but precise shift in its path. The efficiency of this propulsion, measured as specific impulse, was calculated to be far beyond any chemical rocket, consistent with advanced ion or plasma thrusters. Gravity couldn't explain it, solar radiation is constant, and natural outgassing is random. The evidence was building 3. I-Atlas wasn't just moving strangely, it appeared to be actively propelling itself. Chemical composition mysteries. The story gets even stranger when you look at the chemical makeup. According to a leaked memo from the Goddard Space Flight Center, the first full infrared spectrum analysis of 3 I-Atlas yielded a bizarre result. The spectra lit up with incredibly sharp lines of nickel. Now, nickel itself isn't entirely unusual in space rocks. It's often found in iron-nickel alloys. But here's the kicker. In the data for 3 I-Atlas, the signature for iron was almost completely absent. In the entire catalog of known asteroids and comets, a composition of refined nickel without its constant companion, iron, is unheard of. Furthermore, the memo noted the absence of common silicates and carbonaceous compounds. Meteoritics expert Dr. Meenakshi Wadhwa has confirmed that such a separation of nickel from iron requires industrial-scale processing at very high temperatures, a process not known to occur in nature. It suggests a material that has been engineered, not one that formed naturally. The memo was allegedly sealed within hours under a restricted access embargo, but the data was clear. An object with an artificial structure was made of an equally artificial material. Radio echoes and communication patterns. Beyond its motion and materials, the most chilling evidence in the leaked files points toward active technology. According to the logs, radio astronomers reviewing raw data from the Intercept mission flagged a pattern of faint, repeating echoes in the X-band frequency range. These weren't natural radio bursts or cosmic static, they were precise, clipped signals with a high signal-to-noise ratio, bouncing back from 3 I-Atlas at regular intervals. What made this truly shocking was the timing. The interval of the radio echoes mapped almost perfectly to the 90-second rhythm of the object's thermal pulses. It was as if something was pinging the object, and the heat pulses were the response. In one of the leaked chat logs, a veteran telemetry specialist reportedly wrote, "It's like someone is pinging the probe and it's answering. The pattern is too tight for random noise." This completely changed the nature of the investigation. SETI pioneer Dr. Jill Tarter has long argued that a truly intelligent signal would likely be efficient and information-dense, characteristics that align with these alleged repeating echoes. The data suggested it could be an active, responsive probe. Expert analysis and propulsion theory. This is where a very real and very famous scientist enters the picture, Harvard astrophysicist Avi Loeb. While he has not commented on this alleged leak, his previous analysis of Oumuamua via the Galileo project provides a stunning framework. The leaked analysis of 3 I-Atlas goes even further than Loeb's theories. The directed heat pulses and course corrections are consistent with a sophisticated ion drive or a similar propulsion system. But the alleged smoking gun came from a microscopic fragment recovered by the interceptor's dust collector. Under an electron microscope, technicians reportedly saw a lattice of silicon with doped traces of phosphorus, arranged in layers spaced at micron intervals, identical to the architecture of a semiconductor wafer, with visible p-n junctions. A materials scientist would immediately recognize this structure. No known natural process from supernova shock waves to planetary formation can create such ordered, layered microstructures. The memo's summary line, though partially redacted, was legible. Semiconductor structure detected. Artificial origin cannot be excluded. This single finding, if true, moves the conversation from anomaly to artifact. So, what do we make of all this? A 26-kilometer object from another star system, moving at impossible speeds, making its own course corrections. It has a surface that looks like armor, a composition of refined nickel, and it pulses with heat and radio echoes on a perfect 90-second clock. And finally, there's a fragment of what appears to be a microchip. The leaked files, if authentic, present a disturbing and profound reality. The questions are staggering. What is this object's purpose? Where did it come from? And perhaps most importantly, what else has NASA found that we don't know about? Don't forget to like, subscribe, and hit the bell icon for more deep dives into the secrets of science and technology. Thanks for watching InnoVision Tech. What if I told you that in 2017 humanity received its first confirmed visitor from another star system, and we almost missed it completely? This mysterious object, traveling at 26 kilometers per second, defied every law of physics we thought we understood. accelerating away from the sun without any visible explanation. Here's the mind-blowing part. Some of the world's top scientists now believe we may have just witnessed our first encounter with alien technology. Did you know that Oumuamua is still the only confirmed interstellar object we've ever detected, and it's already gone forever? Oumuamua initial detection. On October 19, 2017, the universe delivered humanity its first confirmed interstellar messenger, and it caught us completely off guard. The Pan-STARRS telescope in Hawaii was conducting routine asteroid surveys when astronomers Robert Warwick and his team spotted something extraordinary streaking across the starfield at unprecedented velocity. This wasn't just another space rock cataloged in their database. It was moving too fast, coming from the wrong direction, and following a trajectory that immediately screamed outsider to anyone familiar with solar system dynamics. They named it Oumuamua, a Hawaiian word meaning scout or messenger from afar arriving first, recognizing that this discovery would fundamentally change our understanding of what lurks in the spaces between stars. Within hours of the initial detection, telescopes around the world were frantically tracking this mysterious visitor as it hurtled past Earth at 26 kilometers per second, speeds that dwarfed anything gravitationally bound to our sun. The object had already completed its closest approach to our star and was racing toward the outer solar system, giving scientists only a precious few weeks to study it before it vanished forever into the cosmic void. What made this discovery truly groundbreaking wasn't just that Oumuamua came from another star system, it was the first interstellar object ever detected passing through our cosmic neighborhood, opening an entirely new field of astronomy and raising profound questions about what else might be drifting silently through the galaxy, undetected by our current observation methods. Classification challenges. The moment scientists began analyzing Oumuamua's properties in detail, they realized they were dealing with something that defied every classification system developed over centuries of astronomical observation. Initially tagged as Asteroid A/2017 U1 based on preliminary observations, the object quickly demonstrated characteristics that challenged this hasty designation. Unlike typical asteroids which maintain relatively stable brightness patterns as they rotate, Oumuamua's luminosity varied dramatically by a factor of 10 as it tumbled chaotically through space, suggesting an extremely unusual elongated shape that was unprecedented in solar system astronomy. Even more puzzling, despite approaching within 0.25 astronomical units of the Sun, close enough to vaporize surface materials on most comets, it displayed absolutely no coma, tail, or any other signs of outgassing that should accompany such solar heating. NASA's Jet Propulsion Laboratory and international astronomy teams spent months in heated debates, frantically analyzing spectroscopic data and photometric measurements while flip-flopping between asteroid and comet classifications as new observations contradicted previous assumptions. The confusion reached such levels that by 2018, the International Astronomical Union was forced to create an entirely new category, officially designating it 1I/Oumuamua, the 1I indicating the first confirmed interstellar object, and establishing a new nomenclature system for future discoveries. This classification nightmare highlighted how woefully unprepared our taxonomic systems were for objects originating beyond our solar system, forcing the scientific community to acknowledge that Oumuamua might represent a completely unknown class of celestial bodies formed under conditions and processes entirely different from anything occurring within our sun's gravitational influence. Trajectory analysis. When astronomers reverse-engineered Oumuamua's cosmic journey using sophisticated orbital mechanics calculations, they uncovered an epic tale spanning potentially millions of years across the vast emptiness of interstellar space. The comprehensive trajectory analysis performed by international teams at ESA's European Space Operations Center and NASA's Jet Propulsion Laboratory revealed that this interstellar wanderer had been drifting through the galaxy long before our solar system had even settled into its current configuration of planets and orbital resonances. Using precise astrometric measurements from multiple observatories, researchers initially calculated that tracing its path backward pointed toward the direction of Vega in the constellation Lyra, one of the brightest stars in our night sky. However, deeper analysis incorporating proper motion corrections and galactic rotation models revealed a far more complex story that challenged simple origin theories. the object would have needed approximately 600,000 years to travel from Vega's current position to reach our solar system, yet stellar motion calculations proved that Vega wasn't located in that position 600 millennia ago due to the constant movement of stars through galactic space. This startling discovery proved that Oumuamua was a true galactic nomad with no clear stellar home, having wandered through multiple stellar neighborhoods during its cosmic odyssey. Its hyperbolic trajectory, a mathematically defined path that curves around the Sun once before heading back to interstellar space forever, indicated approach speeds of 44 kilometers per second relative to our Sun at perihelion. Unlike the elliptical orbits of comets and asteroids gravitationally bound to our star, Oumuamua possessed more than enough kinetic energy to escape permanently into the cosmic wilderness, never to return to our solar system again. Photometry and shape analysis. The light measurements of Oumuamua revealed honestly the most bizarre shape ever recorded for any natural object in our solar system. Photometric observations conducted by observatories all over the globe, including the Very Large Telescope in Chile and Gemini Observatory in Hawaii, showed brightness variations that, well, could only be explained by an extremely elongated form. Scientists calculated that Oumuamua was at least 10 times longer than it was wide, with dimensions roughly 400 meters by 40 meters, kind of resembling a cosmic cigar tumbling end over end through space. Dr. Karen Meach from the University of Hawaii led international teams analyzing these light curves, discovering the object completed one full rotation every 7.3 hours. The extreme aspect ratio was totally unprecedented. No known asteroid or comet even came close to such proportions. Some researchers, including Dr. Shmuel Bieli, proposed it might be even flatter, resembling a cosmic pancake rather than a cigar, which honestly would make it even more unusual. The surface appeared reddish, similar to objects in the outer solar system that have been darkened by cosmic radiation over billions of years. However, Oumuamua reflected only about 4% of incident sunlight, making it darker than charcoal. This combination of extreme elongation, dark surface, and rapid tumbling motion created a unique signature that really challenged existing models of how small bodies form and evolve in space, suggesting formation processes completely unlike anything occurring in our solar system. Acceleration anomaly. The discovery that, honestly, shattered every conventional explanation came when precise tracking revealed Oumuamua was accelerating away from the Sun in ways that just defied physics. Dr. Marco Michelli and his international team published their groundbreaking findings in Nature journal in June 2018, documenting a small but measurable non-gravitational acceleration of approximately 4.92 times 10 to the -6 meters per second squared. This wasn't measurement error. Multiple independent observations confirmed that Oumuamua was actually speeding up as it moved away from our star. For typical comets, acceleration like this makes perfect sense. Frozen gases sublimate near the Sun, creating jets that act like tiny rocket engines. However, Oumuamua showed absolutely no signs of this outgassing activity. No visible coma, no tail, no gas emissions detectable by any instrument. The Hubble Space Telescope conducted follow-up observations that confirmed the anomalous motion while ruling out systematic errors or unknown forces. This acceleration was too large to be explained by solar radiation pressure alone, yet too small to be caused by gravitational influences from planets or other bodies. The mystery deepened when scientists realized that whatever was causing this acceleration appeared to be acting continuously and smoothly, rather than in bursts typical of comet outgassing. This unprecedented behavior forced astronomers to consider possibilities they had never seriously contemplated. Either Oumuamua represented a completely unknown type of natural phenomenon, or well, something artificial was responsible for its strange motion through our solar system. Spitzer observations. NASA's Spitzer Space Telescope conducted humanity's final attempt to solve the Oumuamua mystery before the object disappeared forever beyond the reach of Earth's instruments. During November 2017, this infrared observatory pushed its capabilities to the absolute limit, conducting some of the most sensitive thermal measurements ever attempted on such a distant small object. Dr. Davide Farnochia and his team at JPL analyzed the resulting data, hoping to detect the warm signatures of outgassing that might explain the acceleration anomaly. Instead, Spitzer's observations only deepened the puzzle. The telescope detected virtually no thermal emission from Oumuamua. setting strict upper limits on any dust or gas production. If the object were behaving like a normal comet, even minimal outgassing should have created detectable infrared signatures, as solar heating warmed, expelled material. The absence of such emissions meant that if outgassing was responsible for the acceleration, it had to be composed of materials completely invisible to infrared detection. Spitzer's measurements also refined estimates of Oumuamua's size and reflectivity, suggesting it was smaller than initially calculated, possibly only 100 to 200 meters in its longest dimension. This smaller size would actually amplify any outgassing effects, making the lack of detectable emissions even more mysterious. The final Spitzer observations in January 2018 showed Oumuamua continuing its anomalous acceleration while remaining thermally invisible, leading scientists to conclude that conventional comet behavior could not explain this object's properties and motion through our solar system. Artificial origin hypothesis. When every natural explanation failed, Harvard University's Professor Avi Loeb and postdoctoral researcher Shmuel Bialy proposed the unthinkable in a paper published in the Astrophysical Journal Letters in October 2018. They suggested that Oumuamua might actually be artificial, specifically a light sail created by an extraterrestrial civilization. This hypothesis, honestly, elegantly explained the acceleration anomaly. A thin, flat object could be pushed by solar radiation pressure without requiring any outgassing. For this mechanism to work, Oumuamua would need to be incredibly thin, less than 1 millimeter thick, while still maintaining its observed dimensions. Loeb proposed it could be debris from alien technology, possibly millions of years old, just drifting through space like cosmic junk from a long-dead civilization. The light sail hypothesis explained not only the non-gravitational acceleration, but also the object's extreme elongation and its unusual tumbling motion. Dr. Loeb argued that extraordinary claims require extraordinary evidence, but, extraordinary evidence also requires extraordinary hypotheses. The scientific establishment reacted with fierce criticism, with many astronomers arguing that invoking alien technology violated Occam's razor, the principle favoring simpler explanations. However, supporters pointed out that dismissing the possibility without proper investigation could actually represent a form of cosmic prejudice. The debate raged across scientific journals and conferences, with researchers split between those demanding more conventional explanations and others willing to consider that humanity had encountered its first piece of alien technology, even if we couldn't definitively prove it. Dark comet theory. Dr. Daryl Seligman from the University of Chicago proposed a revolutionary alternative that really challenged our understanding of comet composition and interstellar chemistry. The dark comet hypothesis, which was published in the Astrophysical Journal back in 2020, suggested that Oumuamua could actually be made mostly of frozen molecular hydrogen. In the extreme cold of interstellar space, where temperatures are around 14 Kelvin, hydrogen can freeze into solid ice that would stay stable for millions of years. As Oumuamua got closer to our sun, this hydrogen ice would sublimate directly into gas, but unlike water vapor or other typical comet materials, hydrogen gas is almost completely invisible to most astronomical instruments. This invisible outgassing could explain the mysterious acceleration without creating any visible coma or tail. The theory goes on to suggest that Oumuamua formed billions of years ago in a giant molecular cloud. Those vast regions of space where gas and dust come together before forming new stars and planetary systems. These environments could create really unique conditions for hydrogen ice to build up, making objects unlike anything we've seen in our own solar system. Seligman's calculations showed that a hydrogen iceberg about the size of Oumuamua could stay intact during its journey through interstellar space, and provide enough outgassing to explain the observed acceleration. This hypothesis opened up the possibility of an entirely new class of interstellar objects that might be drifting undetected all over the galaxy, basically invisible to our current observation methods, because their outgassing doesn't produce any visible signatures that our telescopes can pick up. Dark comet classification. The implications of the dark comet theory went way beyond just Oumuamua. It could totally revolutionize the way astronomers classify small bodies in space. Researchers at NASA's Jet Propulsion Laboratory started developing new classification systems to account for objects that show non-gravitational acceleration, but without any visible activity. Scientists began to propose distinguishing between small dark comets like Oumuamua, which came from interstellar space and potentially large dark comets that might actually exist within our own solar system, just unrecognized up until now. Dr. Daryl Seligman and his colleagues even identified several objects in the solar system database that showed unexplained acceleration without obvious outgassing, suggesting that dark comets might be way more common than we ever imagined. The new classification parameters included things like thermal emission signatures, spectroscopic properties, and acceleration magnitudes that are really different from what we see with traditional comets and asteroids. This new framework suggested that maybe our telescopes have been missing a whole population of hydrogen-rich objects simply because our detection methods are tuned for water-ice comets and rocky asteroids. The European Space Agency even started to include dark comet detection protocols in their future mission planning, realizing that interstellar visitors could be a lot more common than just the single confirmed case of Oumuamua. Some researchers estimated that if the dark comet hypothesis is correct, the galaxy could have billions of these invisible objects, creating a hidden population of interstellar wanderers that occasionally pass through planetary systems without us even noticing. This whole idea really changes our understanding of how material is distributed across the galaxy, and it suggests that the space between stars could be way more crowded with small bodies than our astronomical models had predicted. Scientific debate. The Oumuamua controversy has basically split the astronomical community into competing camps, each one defending some pretty radically different interpretations of the same data. Team Natural, led by researchers at NASA's Goddard Space Flight Center and the European Southern Observatory, insists that conventional physics has to explain the acceleration anomaly, and they propose things like outgassing of common volatiles or internal changes during solar heating. Then there's Team Artificial, led by Harvard's Avi Loeb and backed by researchers from Tel Aviv University, who argue that the light sail hypothesis deserves serious scientific consideration, and shouldn't just be dismissed because people are skeptical about extraterrestrial explanations. Team Dark Comet, centered around researchers at the University of Chicago and Yale University, is pushing the hydrogen iceberg theory and working on ways to detect similar objects. The debate has been going strong in top scientific journals like Nature, Science, and the Astrophysical Journal since 2018, and honestly, each new analysis seems to make the mystery even deeper. Dr. Alan Fitzsimmons from Queen's University Belfast leads the skeptics, saying that these exotic explanations go against scientific principles, while Dr. Abraham Loeb's supporters counter that extraordinary evidence demands extraordinary hypotheses. Recent studies have even found more solar system objects with similar properties, which could support the dark comet classification. The scientific process is working exactly as it should. Competing hypotheses are driving new observations and new theories. Whether Oumuamua was natural, artificial, or something totally unprecedented, it's already changed astronomy by showing that interstellar objects can really challenge our most basic assumptions about the universe, forcing scientists to broaden their frameworks for understanding cosmic phenomena. So, there you have it. Oumuamua is still one of the greatest mysteries in modern astronomy, challenging just about everything we thought we knew about interstellar objects. Whether it was a natural dark comet, alien technology, or something completely unprecedented, this cosmic visitor has forever changed the way we see our place in the universe. What's your theory? Was Oumuamua our first glimpse of extraterrestrial engineering, or does nature still have more surprises up its sleeve? Drop your thoughts in the comments below. I read every single one. And if you're fascinated by these mind-bending space mysteries, go ahead and smash that subscribe button and hit the bell icon so you never miss the latest discoveries from InnoVision Tech. Until next time, keep looking up. What if the mysterious object racing through our solar system isn't what it appears to be? Fresh observations of 3I/Atlas are revealing characteristics so unusual that some scientists are questioning whether we're dealing with a natural comet at all. This interstellar visitor's trajectory, timing, and behavior patterns are defying conventional explanations, leading to heated debates in the scientific community. Today, we'll examine the mounting evidence that suggests this cosmic wanderer might be far more extraordinary than anyone initially imagined, and explore the controversial possibility that we could be witnessing something truly unprecedented. Discovery and initial detection. The story of 3I/Atlas begins with a routine sky survey that would soon turn extraordinary. On July 1, 2025, the Atlas telescope system at Rio Hurtado Observatory in Chile captured images of an unusual fast-moving object designated A11PL3Z. Larry Deneau from the University of Hawaii's Institute for Astronomy immediately recognized that this wasn't an ordinary solar system object. Within days, follow-up observations confirmed what astronomers had suspected. This was the third confirmed interstellar visitor in human history, joining the ranks of 1I Oumuamua discovered in 2017 and 2I Borisov found in 2019. The object received multiple designations, 3I Atlas for its interstellar status, and C2025N1 for its cometary characteristics. What made this discovery particularly intriguing was that despite entering our solar system weeks earlier, 3I Atlas had remained undetected due to its challenging viewing angle against the dense star fields near Sagittarius. John Tonry, principal investigator of the Atlas project, noted that pre-discovery images dating back to June 14, 2025 revealed the object had been silently approaching our solar system for an extended period. This late detection would prove to be just the first of many unusual characteristics that would set 3I Atlas apart from any cosmic visitor we'd ever encountered. Extraordinary orbital characteristics. Prepare to have your mind blown by the absolutely extraordinary orbital mechanics of this interstellar wanderer. Davide Farnocchia from NASA's Jet Propulsion Laboratory has calculated that 3I Atlas follows a hyperbolic orbit with an extreme eccentricity of 6.14, the highest value ever recorded for any known interstellar object. This mathematical measurement indicates just how dramatically different this visitor's path is from anything bound to our solar system. Even more remarkable is its incoming velocity of 58 kilometers per second, making it the fastest interstellar visitor ever recorded approaching our cosmic neighborhood. But here's where things get truly suspicious. The trajectory lies almost perfectly within the ecliptic plane, the flat disk where most planets orbit the Sun. Marco Micheli from the European Space Agency has calculated that the probability of this alignment occurring by random chance is merely 0.2%. This isn't just unusual, it's astronomically improbable. Most objects from interstellar space would approach from random angles, yet 3I Atlas chose a path that seems almost deliberately designed for optimal planetary encounters. The precision of this trajectory has prompted some researchers to question whether we're witnessing natural celestial mechanics or something far more intentional. Such mathematical precision in cosmic trajectories typically requires either extraordinary coincidence or deliberate planning. Suspicious planetary encounters. The planetary encounter sequence of 3I Atlas reads like a carefully choreographed cosmic ballet that defies statistical probability. Robert Warwick from the University of Western Ontario, who previously discovered Oumuamua, has analyzed the object's path and found it passes unusually close to Venus, Mars, and Jupiter during its solar system transit. The probability of such close encounters occurring randomly has been calculated at an astounding 0.005%, essentially impossible by chance alone. But the timing gets even more suspicious. Paul Chodas from NASA's Center for Near-Earth Object Studies has determined that 3I Atlas reaches its closest approach to the Sun precisely when Earth would be positioned on the opposite side, blocking direct observation during the most critical phase of its visit. The statistical probability of this alignment? A mere 7% chance. Karen Meach from the University of Hawaii has noted that rather than resembling the chaotic path of a randomly ejected comet, the trajectory appears optimized for studying the inner solar system planets while minimizing detection risks. This orbital choreography provides optimal vantage points for comprehensive planetary observations, exactly what you'd expect from a reconnaissance mission rather than a chance cosmic encounter. The mathematical precision required for such a trajectory suggests either unprecedented natural coincidence or deliberate design by an intelligence capable of interplanetary navigation. Physical properties and anomalies. The physical characteristics of 3I/Atlas are equally perplexing and honestly challenge our understanding of typical interstellar objects. Daryl Seligman from Michigan State University has determined that the object measures somewhere between 1 to 12 kilometers in diameter, making it significantly larger than both previous interstellar visitors and providing an unprecedented opportunity for detailed study. Spectroscopic analysis suggests this cosmic wanderer is extraordinarily ancient, potentially 7 billion years old, predating our entire solar system by billions of years. This makes it a genuine cosmic fossil, carrying secrets from the early epochs of our galaxy. Quanzi Ye from the University of Maryland has confirmed that 3I/Atlas is the brightest interstellar object ever observed, allowing for detailed spectroscopic analysis that just wasn't possible with previous visitors. Perhaps most intriguingly, the object exhibits a 29-hour rotation period with minimal brightness variation, suggesting either a spherical shape or a uniform surface composition, characteristics that are pretty unusual for natural comets. Matthew Knight from the Naval Research Laboratory has noted that high-resolution observations reveal a remarkably compact and dense appearance, lacking the typical fuzzy, diffuse structure expected from ancient comets. These physical properties suggest either an unusually well-preserved natural object or something with a fundamentally different composition and structure than anything we've previously encountered in our solar system. Comet-like features versus anomalous behavior. Here's where 3I/Atlas becomes truly enigmatic. It displays some comet-like characteristics while simultaneously exhibiting behavior that frankly just defies cometary physics. Alan Fitzsimmons from Queen's University Belfast has confirmed that the object shows a faint coma and a short tail measuring approximately 3 arc-seconds, indicating active outgassing as solar radiation heats its surface. Spectroscopic observations have detected the characteristic signature of sublimating water ice, producing the dust and gas envelope typical of approaching comets. However, Tony Farnham from the University of Maryland has noted several anomalies that challenge this interpretation. Despite its proximity to the Sun and evidence of outgassing, 3I/Atlas maintains a remarkably compact, dense appearance that differs dramatically from the fuzzy, diffuse structure of typical comets. Most puzzling is the absence of an expected extended tail, which really should be prominent given the object's size and solar distance. Bin Yang from the European Southern Observatory has observed that the outgassing patterns don't follow standard cometary models, with irregular brightness variations that suggest complex subsurface processes. The combination of active sublimation with maintained structural integrity presents a paradox. How can an object simultaneously behave like a comet while retaining characteristics more consistent with a solid, engineered structure? This contradiction has sparked intense debate about whether we're observing natural cometary processes or something fundamentally different masquerading as a comet. Scientific debate: natural versus artificial. The scientific community has erupted into heated debate over the true nature of 3I/Atlas, with interpretations ranging from exotic natural phenomena to, well, potentially artificial origins. Avi Loeb, the Frank B. Baird Jr., professor of science at Harvard University, has emerged as the most vocal proponent of considering artificial origins, pointing to the statistically improbable trajectory and suspicious timing as evidence that, in his view, warrants serious investigation. Loeb argues that the mathematical precision of the object's path, combined with its optimal positioning for planetary reconnaissance, exceeds reasonable expectations for random cosmic events. His Galileo project at Harvard has been mobilized to conduct systematic observations using multiple telescopes worldwide. However, mainstream astronomers have pushed back strongly against these suggestions. Sarah Seeger from MIT acknowledges the unusual characteristics while emphasizing the importance of exhausting natural explanations before considering extraordinary possibilities. Robert Yedecke from the University of Hawaii has criticized speculation about artificial origins as premature and potentially damaging to scientific credibility. The debate highlights fundamental questions about how we interpret anomalous data and the threshold of evidence required for paradigm-shifting discoveries. Alan Stern, principal investigator of the New Horizons mission, has noted that while the characteristics are unusual, the universe is full of phenomena that initially appear impossible until we develop a better understanding of the underlying physics. Spectral analysis mysteries. The spectroscopic data from 3I/Atlas is revealing some puzzling inconsistencies that are, honestly, challenging our understanding of interstellar object composition. Stephanie Malam from NASA Goddard Space Flight Center has been coordinating observations using the James Webb Space Telescope to conduct detailed infrared spectroscopy of the object's composition. Initial results confirm the presence of water-ice spectrum, but the patterns just don't match our expected models. Jacqueline Keene from Boston University has identified these anomalous spectral signatures, where the observed signals actually increase in regions where water ice models predict they should decrease. This contradiction suggests either unknown compositional elements or maybe structural properties that don't conform to standard cometary models. Now the object exhibits a distinctly reddish coloration, similar to objects in our outer asteroid belt, yet its interstellar origin kind of rules out formation in our solar system. Michelle Bannister from the University of Canterbury has noted that attempts to determine precise composition are complicated by the active coma surrounding the nucleus, which creates interference in spectral measurements. Julie Castillo-Roges from NASA's Jet Propulsion Laboratory has suggested that these unusual spectral characteristics might indicate exotic ice compositions or internal structures not found in solar system objects. So, these spectroscopic mysteries really add another layer of intrigue to an already enigmatic visitor, suggesting that 3I Atlas may be composed of materials or structured in ways we just don't yet understand. Dark forest hypothesis implications. The behavior patterns of 3I Atlas align remarkably well with theoretical models of how an advanced civilization might conduct reconnaissance while avoiding detection. The dark forest hypothesis, popularized by Chinese science fiction author Liu Cixin, suggests that intelligent civilizations remain hidden to avoid potential threats from other species. Seth Shostak from the SETI Institute has noted that 3Y Atlas exhibits what could be interpreted as stealth-like behavior, deliberately timing its closest solar approach when Earth would be positioned to block optimal observation. This timing ensures that the most detailed study phase occurs when our planet's scientific instruments have limited access to the visitor. Jill Tarter, former director of SETI research, has observed that the trajectory allows for comprehensive surveying of inner solar system planets, while minimizing exposure to potential detection by any resident intelligence. The orbital path provides optimal vantage points for studying Earth's atmosphere, Mars's surface conditions, and Venus's cloud dynamics, exactly the type of data an exploring civilization would prioritize. Frank Drake, creator of the famous Drake equation, noted before his passing that such reconnaissance patterns would represent logical exploration strategies for risk-averse civilizations. While most scientists remain skeptical of artificial explanations, the behavioral patterns of 3I Atlas do match theoretical models of how cautious interstellar explorers might operate when encountering potentially inhabited star systems. Historical context and lessons. The discovery of 3I Atlas comes with profound lessons learned from our missed opportunities with previous interstellar visitors. When 1I Oumuamua was discovered in 2017, the scientific community was caught completely unprepared for studying such a rare phenomenon. Robert Warwick, who discovered Oumuamua using the Pan-STARRS 1 telescope, has reflected on how the object's rapid departure left many critical questions unanswered. The mysterious acceleration exhibited by Oumuamua without visible outgassing remains unexplained to this day, highlighting the importance of comprehensive observation campaigns. Gennady Borisov, the amateur astronomer who discovered 2I Borisov in 2019 from his observatory in Crimea, provided the astronomical community with a second chance that was better utilized. However, even Borisov's study was limited by available technology and coordination protocols. Mark Norris, from the University of Central Lancashire, has emphasized that 3I Atlas represents our most comprehensive opportunity yet to properly study an interstellar visitor with advanced instruments and coordinated global observation campaigns. The improved detection capabilities of modern sky surveys, combined with rapid communication networks, have enabled real-time coordination among observatories worldwide. Michelle Bannister has noted that the lessons learned from previous interstellar encounters have fundamentally changed how the astronomical community approaches these rare events, ensuring that we're better prepared to unlock the secrets these cosmic messengers carry from distant star systems. Future observations and implications. The coming months represent a critical window for determining the true nature of 3I Atlas before it departs our solar system forever. Perihelion is scheduled for October 30, 2025, after which the object will begin its journey back toward interstellar space. Paul Chodas has calculated that 3Y Atlas will re-emerge from behind the Sun in December 2025, providing a final opportunity for detailed observations before it becomes too distant for meaningful study. Karen Meach is coordinating an unprecedented international observation campaign involving over 50 professional observatories and numerous space-based instruments. The Hubble Space Telescope, James Webb Space Telescope, and ground-based facilities including the Very Large Telescope in Chile are all dedicating precious observation time to this cosmic visitor. Daryl Seligman has noted that the data collected during this campaign will either confirm 3I Atlas as an exotic but natural interstellar comet, or potentially revolutionize our understanding of what's possible in our cosmic neighborhood. The implications extend far beyond pure astronomy. If 3I Atlas proves to be artificial, it would fundamentally alter humanity's perspective on our place in the universe and our approaches to planetary defense and interstellar communication. Alan Fitzsimmons emphasizes that regardless of the final interpretation, 3I Atlas represents a pivotal moment in astronomy, where advanced technology meets unprecedented opportunity to study materials and possibly intelligence from beyond our solar system. As 3I Atlas continues its mysterious journey through our solar system, it challenges everything we thought we knew about interstellar visitors. Whether this ancient wanderer is an exotic natural phenomenon or something far more extraordinary, it's forcing us to expand our understanding of what's possible in the cosmos. The next few months will be crucial in determining the truth about this enigmatic visitor before it disappears back into the depths of space. Stay tuned to InnoVision Tech for the latest updates on this cosmic mystery. Share and subscribe.